Ladies and gentlemen, boys and girls, welcome to a very special edition of Absolute Science. Everyone yell, Absolute Science! Great job, everyone. Now, my name is Professor Toto, and I'm going to be your guide today for some really cool science experiments. Who's ready to have some fun? I can't hear you. Who's ready to have some fun? Let's get started. I love to have fun. I love to be silly. But I also know that while I'm doing my science experiments, I need to be safe. So you might have noticed that at the end of my table, I have a fire extinguisher. I'm also going to be using a fireproof mat. You see, everyone, I have very special permission today to use fire in the show. Now remember, boys and girls, you should never play with fire. I've been trained how to use it safely. And of course, I have all of my safety equipment. So let's get started with the very first experiment. And in order to do my first experiment, I'm going to need a helper from the audience. Now, because it's a very special show and I don't have a full audience here with me, today I have asked a very good friend to help me. I would like to ask Iowa's youngest magician, Kaylee Rogers, to join me on stage. Everybody at home, give Kaylee a big round of applause. Come right up, Kaylee. I'm going to have Kaylee stand right over here on this side for our first experiment. Now, Kaylee, take one more step over this way, right there. You see, Kaylee, your job is to hold this. This is the very expensive Cup of Science. Ooh, everybody say, ooh. That's right, I paid $1 for this at a very fancy store. It's a French store called Target. That's right, it cost $1, and Kaylee, you get to hold that just like that. Let's begin our experiment. Here I have, a heavy metal pipe. And I've covered this pipe with duct tape so all of you can see it. Next, I am going to heat the inside of the pipe using this propane torch. I need the inside of this pipe to reach over 900 degrees. Everybody say, oh yeah. Oh, yeah. Let me put this right there while I turn on the torch. Here we go. I am going to take about 45 3/4 seconds to heat the inside of this pipe. It's getting hotter and hotter and hotter. But don't worry, it won't burn my fingers. I can feel the pipe getting warm, but it's not going to get so hot that I cannot hold it. We're about halfway there. We can start counting in just a few more seconds while the pipe is reaching how many degrees? That's right, over 900 degrees. We're almost ready. So boys and girls, help me count backwards from 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh wait, no. I don't need that sound here. Let me turn this off. There we go. I'm going to pour that into the cup, Kaylee, just like that. You see, we don't need, hey, no, we don't need that sound. I'll pour that into the cup. There, we don't, hey, wait a minute. I said we don't need that sound. I'll pour that into the cup. You see, this doesn't use sound. Hey, wait, no, we're not supposed to have sound. I'm going to pour that into the cup, just like that. See, there's no more, wait, there's more sound. We don't need that sound, Kaylee. Oh, I hope the cup's not getting full. Hey, I think there's a little bit more. Let's pour that in. We don't need that at all. There, I think that should be good. We're all done with the sound. So let's give Kaylee a big round of applause. Thank you so much, Kaylee. You can go right back to your seat. Boys and girls, do you think that I really filled this cup full of sound? Of course not. You can't fill a cup with sound. But I am going to tell you the science behind this. You see, everyone, inside the metal pipe, well, right about here, there's a little metal screen. It looks a lot like this one right here. And I pushed it up inside the pipe. Then, when I used the torch to heat the inside of the pipe, to how many degrees? Over 900 degrees. This little metal screen gets red hot. Then, when I take the torch away, the cool air from up underneath the pipe gets drawn through, just like smoke in a chimney. When the cool air goes through that red hot screen, it produces a musical tone. But if I turn the pipe this way, can air go in now? No, so that makes the sound stop. But if I turn it this way, can the sound come out through the air going through the pipe? Of course. So let's do that trick one more time. Let's see if we can recreate the experiment. I'm going to turn on. Oh! Whew, that was close. Let's heat the inside of the pipe again. Now this time we won't have to let it fully heat up again because it's still a little warm from our first experiment. So let's heat that up to over 900 degrees. We're going to get very, very close. We're already up to 776 degrees. So let's all count backwards from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And there is our musical tone. Now the air is being drawn up through the pipe from underneath. But if I turn it this way, the air isn't drawn up, so it stops. And if I hold it this way, we have our sound. This way, no sound. This way, lots of sound. Ladies and gentlemen, boys and girls, this is a... Ladies and gentlemen, boys and girls, this is a... Ladies and gentlemen, boys and girls, this is my musical pipe. And it's absolute science. Well, let's go on to our next experiment. But first, I need to start putting everything away as I use it. You see, everyone, at the end of the show, for the grand finale, I'm going to need all three of my tables to be open and clear. So as I do the show today, I'm going to put things away. Oh, look, half of the table is already clear. That means I can go on to the next experiment. And it's right over here. Here I have lycopodium. Everyone say lycopodium. Lycopodium is a club moss, and it's been used in medicine for a very long time. Lycopodium is used to treat ailments of the gallbladder and the liver. It's also been used to coat medication. Now, lycopodium is odorless. Lycopodium is water resistant. But my favorite part of lycopodium, it's highly flammable. That means it catches on fire and we get to do some experiments with it. So let's get started. I'm going to pour some lycopodium into this beaker that's half filled with water. Look at that. Can you see how the lycopodium floats on the top of the water? Let me show you what happens next. I am going to put my fingers into the lycopodium. Watch carefully. Whoa! Look at that, everyone. Can you see that the lycopodium is clinging to my fingers? Now, you might think that my hand and the lycopodium are all wet, but watch this. Perfectly dry. Let me do that again. My hand goes down into the lycopodium, and it coats my fingers just like it coats medication. And now my hand is covered in highly flammable powder. I don't want my hand coated in highly flammable powder. I'm going to wipe my hand off. I have some wet ones right here. because nobody ever wants to coat their fingers in highly flammable powder. Unless there's somebody in the audience today that would like to try it. Let's see, who can I pick? Of course I'm going to pick my friend Kaylee. She's the only kid here today. Come on up here, Kaylee. Give Kaylee another big round of applause. I'm going to have Kaylee come stand right over here. Smile at everyone. Excellent job, Kaylee. Now I'm going to have you put your fingers in the highly flammable powder. Are you ready? All right, Kaylee, I will hold the beaker. I will help guide your hand. Watch Kaylee's hand. Whoa, can you see that? Now pick your hand up, Kaylee, and shake your fingers off a little bit. Show everybody that they're dry. Let's do that again. Fingers together, Kaylee, down into the lycopodium. Whoa, everybody say whoa. And back up. Shake your fingers off, Kaylee. Now keep your hand right there, Kaylee. You are covered in highly flammable powder. I don't want to send you back to your seat covered in highly flammable powder. So I am going to get you a wet one. You can wipe your hands off. And guess what, Kaylee? You get to keep it as a souvenir of the show. Give Kaylee a big round of applause. Great job, Kaylee. I'm sure I'll see you again during the show. Well, now we know that lycopodium really is water resistant. But that's not my favorite part. My favorite part is that it's highly flammable. So now let's do some fire experiments. Here I have a little container of lycopodium. I am going to take a lighter and make it catch on fire. Are you ready? Here I go. Watch this. Wait a minute. Watch this. Well, I thought lycopodium was supposed to be flammable. It is, but not in a container like this. Oh, and not in a big container like that either. You see, everyone, in order for lycopodium to become flammable, I have to do this. Watch the air. Can you see that dust? That dust is highly flammable. That's right, it's exactly the same thing when a grain elevator explodes. It's not the grain that explodes. It's all that dust in the air. So I'm going to show you an experiment that uses that dust in the air to make our homemade absolute science flamethrower. Everybody say, cool. I am going to get my homemade flamethrower. Here it is. I have a lighter. Connected to the lighter is some plastic tubing. And inside the plastic tubing is lycopodium. In just a moment, I'm going to come out front of the table. I am going to blow gently into the tubing, across the flame, and we'll all see what happens. Are you ready? You don't sound ready. Are you ready? I'm ready. Here we go. Ladies and gentlemen, boys and girls, our homemade, absolute science, lycopodium flamethrower. Whoa! Should I do that one more time? Let's do that one more time. Everybody, 1, 2, 3. And there it is. It's our homemade flamethrower. But I think I can see myself doing one more flammable lycopodium trick. Would all of you like to see a flammable waterfall? Did you know that I can light water on fire? I'm going to do that right now for you. Let me get our lycopodium that is already in the water. I'm going to get a lighter. In just a moment, I am going to pour the water and the lycopodium into the bucket below. I am going to light that lycopodium on fire, and we will see a fireball in a waterfall. Are you ready? Here we go. Whoa! Should I do it again? Here we go. And there it is, a lycopodium flammable waterfall fireball. And it's absolute science! Now, boys and girls, what do I do after every experiment? I clean up. So I'm going to start cleaning up right over here. I'm going to put some of this away. I am going to need all 3 tables, open and clear, for the end of the show. Whoa! Look at that! An entire table is clear. That means I can go on to my next experiment. Now everyone, my boss at Absolute Science, Professor Rick, he said, Professor Toto, I would like you to do a very special experiment that you have never done before. So I chose this one, right over there. It involves a bottle of Diet Coke. And it also uses something called Mentos. Wait. Did I hear some of you say that you know what this experiment does? Oh, well, don't tell me. I want to learn for myself. I know that I need to put 7 Mentos into this tube. So everyone help me count 7 Mentos. 1, 2, 3, 4, 5, 6, and 7. 7 Mentos are in the tube. Now let's take the top off of the Diet Coke, just like this. And I'm going to put a little bit of this tape on the top because we want a nice tight fit between the tube and the top. So let's put a little bit of tape there. And then I will attach the tube to the top, just like that. That looks perfect. So in just a moment, I'm going to count to 3. When I do, I'll pull the magnet off of the tube. The Mentos will drop into the Diet Coke, and we'll all find out what happens. Are you ready? Everyone, help me count to 3. 1, 2, 3. Oh, wait. I almost forgot. I'm supposed to add something to the top. Ladies and gentlemen, boys and girls, presenting the Absolute Science Exploding Soda Pop Distributor! This distributor gets attached to the top of the tube. I need to tighten it up just like this. Ooh, perfect. Now I'm ready to do the experiment. In just a moment, I'm going to pull the magnet off of the tube. The Mentos will drop into the Diet Coke, and we'll all find out what happens. Are you ready? Help me count to 3. 1, 2, wait. I'm still not ready. You see, everyone, there are 6 tubes coming down, so we need 6 cups. Everyone, help me count to 6. 1, 2, 3, 4, 5, and 6. Now I really am ready. When I count to 3, I'm going to pull the magnet off of the tube. The Mentos will drop into the Diet Coke, and we'll all find out what happens. Are you ready? Are you really ready? Then everyone, help me count to 3. 1, 2, 3. Here we go. There we go. Whoa! Look at that! Did you know that was going to happen? You did? Well, let me tell you why it happens. You see, everyone, when the Mentos dropped into the Diet Coke, the carbon dioxide gas bubbles inside the Diet Coke collected in all the little pits on the surface of the Mentos. Eventually, those carbon dioxide gas bubbles got so big that they shot up through the tube, across the top, and down the spouts into the cups. Ladies and gentlemen, boys and girls, this is a Diet Coke and Mentos experiment, and it's absolute science! Now remember, after every experiment, I need to clean up. I'm going to need all of my tables to be open and clear for the end of the show. So I'm going to move everything over to the side because I don't need any of this. Now remember, kids, you can't drink the Diet Coke after you do this experiment. Number one, when we did the experiment, we released almost all of the carbon dioxide gas bubbles. So now, there's no bubbles left in our Diet Coke. That's no fun. The second reason is there's now Mentos in there. And the taste of Mentos in Diet Coke? No good at all. But the main reason we cannot drink it is there's now a magnet in the Diet Coke. And if you drink a magnet in your Diet Coke when you go home, you stick to the refrigerator. We can't have that. So we're going to put all of that away. And wait, look at this. My second table is clear. That's 2 tables clear. 1 more to go. We just did a physical reaction experiment. Now it's time to do a chemical reaction experiment. And in this experiment, I'm going to be using some dangerous chemicals. So I am going to put on my rubber gloves. Let me put on my rubber gloves. And for this experiment, I am going to need the help of my laboratory assistant. So let's all give a big round of applause for laboratory assistant Mary. Here she comes. Now, Mary, I'm going to have you stand right about here. Just like that. You'll get to watch the first part of this experiment, but I will need your help for the second part. Here we go. In my first beaker, I have water. Oh, but water by itself is not very exciting. So I'm going to add something to the water. I'm going to add a little bit of sodium hydroxide. Everyone say sodium hydroxide. Nice job. I add just a little bit. Ooh, not too much. Now let's move on to beaker number 2. In beaker number 2, I'm going to add phenolphthalein. Everyone say phenolphthalein. Just a little bit. Ooh, not too much. Now let's see what happens when I add beaker number 1 to beaker number 2. It might explode in a huge fireball of doom. Let's find out. Beaker number 1 into beaker number 2. Watch this. Whoa! That's amazing! We created a chemical reaction. But wait, there's more. This is a basic solution. It's time now to add some acid. The acid is going to go into beaker number 3. And the type of acid I'm going to use is hydrochloric acid. Everybody say, oh no.
Oh no.
Oh yes. Hydrochloric acid can dissolve aluminum foil. Hydrochloric acid can eat through metal. But the worst part of hydrochloric acid for me is it smells terrible. So I'm going to hold my breath while I'm pouring it. Ladies and gentlemen, boys and girls, hydrochloric acid. Here we go. Oh. Just a little bit, not too much. Now let's see what happens. I pour beaker number 2 into beaker number 3. Nobody blink. Whoa! It became clear again, and the acid and the base are neutralized. But let's all take this another step further. Let's use this principle to create some ink. We are going to create ink with the assistance of Mary. Mary, I want you to stand right there. I'm going to create the ink, then you will come in to help me. I'm going to start with this glass flask. And to the glass flask, I'm going to add some ethanol. Everyone say ethanol.
Ethanol.
Just a little bit. Not too much. Then comes the phenolphthalein. Everyone say phenolphthalein. Just a little bit. Ooh, not too much. I am now going to add water. I'm going to add a lot of water. Let's get some water. Here we go, a lot of water. Water, 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 water. That's a lot of water. Even more water. That's plenty of water. It's time now to ask one more time, what should I add? That's right, I'm going to add sodium hydroxide. Say, don't do it.
Don't do it.
I'm going to do it. Just a little bit, not too much. Whoa! Look at that! We created pink ink. Let me put this away. And I'm going to make sure I wipe off this glass flask. Now that we have ink, we have to be very, very careful with it. We don't want to get it on anything or anyone. Oh, Mary, would you please help me? I want to make sure we're very careful with this. So would you please hold that? Be very careful with it. Now, boys and girls, do any of you want to be scientists when you grow up? Would you like to be a scientist? I've wanted to be a scientist ever since I was just 5. What's so funny? I wanted to be a wait, no. Science is not funny. I wanted to be a scientist since I was just 5 years. Is it raining in here? 5 years old. I've always. Hey, wait a minute! Wait! How did this pink ink get on me? Who did this? Did you do this? Who? My lab assistant did this? Mary, you've ruined my lab coat. Oh, I'm just kidding. You see, both Mary and I know that the kind of ink we made today is actually disappearing ink. Do you remember when I took the pink and I poured it into the hydrochloric acid and it disappeared? Well, that's what's going to happen with the ink on my lab coat. Except we're not putting hydrochloric acid on my lab coat. Remember when we talked about carbon dioxide gas in our Mentos experiment? Well, carbon dioxide gas is slightly acidic, and the carbon dioxide gas in the air is going to react with the pink on my lab coat. During the rest of the show, you will slowly see the pink disappear. Ladies and gentlemen, boys and girls, lab assistant Mary and I created pink ink, and it's absolute science! Great job. Well, I am going to clean up one more more time because it is almost time now for the grand finale. So I'm going to put my beakers right over here, and I'm going to take off my rubber gloves. I won't need those. Whoa! Look, everyone. 1, 2, 3 tables are open, which means it's time now for the grand finale. And for the grand finale today, I'm going to be using a laser. How many of you like lasers? Well, a laser's light is created when the electrons in certain types of glasses, gases, or crystals absorb energy from an electrical charge. And they get really exciting. My laser is a class 4 blue, high-powered burning laser. And it's so powerful that I'm going to have to wear special safety glasses in order to use it. But don't worry, boys and girls, through the magic of video and a special screen that I'm going to put up, you will be able to watch these laser experiments perfectly safe. So while my assistants and I get ready, please enjoy this musical interlude. Wait, I won't sing. We'll just get set up. We'll be back in just a moment. Ladies and gentlemen, boys and girls, welcome to the grand finale of Absolute Science. Here is my Class 4 blue, high-powered burning laser. I am ready to begin my first of 3 experiments. Each one is a little bit bigger than the one before. And because we are on video, I did not have to put up my protective screen. All of you will be protected by the video. I'm going to start by seeing if I can light a match using just my laser. Are you ready? Here we go. Watch the match. Whoa! That worked! But was that a big laser experiment? Of course not. We need to do experiment number 2. Experiment number 2 is going to use a bucket hanging from a string. I'm going to see if I can use my laser to burn right through the string so the bucket falls on the table. Do you think my laser can do that? Let's find out. Here we go. 1, 2, 3. It did it! Amazing! But was that a big laser experiment? No. We need to go on to the grand finale. And for the grand finale, I am going to attempt to pop 8 balloons with my laser. Now, the world record is 12, but I don't have 4 more balloons. I just have 8. What's that? You see 4 more? Where? No, I don't have... You're right. I do have 4 more balloons. Should I try to go for the world record of 12? Let me get my 4 more balloons. I'm going to put my laser right over here. I'm going to get 4 more balloons to see if we can set the world record. Now, if I do this, I want each and every one of you watching to go bananas! Are you ready for the grand finale? Ladies and gentlemen, boys and girls, for the world record, help me count to 5. 1, 2, 3, 4, 5. Class 4 blue, high-powered burning laser, and it's absolute science! Well, I hope you all had fun today, and I hope you learned a little something along the way. Remember, kids, if you love science as much as I do, there are lots of great science books at your local library. Make sure you stop by when the library is open. Ask the librarian to help you find them. You'll be glad you did. And remember, kids, when you are in school, make sure you ask your teachers about science. Everybody loves science. On behalf of everyone at Absolute Science, my name is Professor Toto. Thanks for being a part of our show today, and we hope to see you soon. Bye-bye, everybody!